G'day, welcome to MAT114 functions. So for this first part, I just called it review, also known as everything from the first semester shoved into 1 or 2 hour long presentation to get us up to speed. So this is kind of going back to what we talked about throughout the first semester, just kind of things that we might need to know that might help us later on in this class here. So the first thing we talked about after we talked about sets, this was in section R.3, where we talked about polynomials. So again, polynomials are just expressions where we have what are known as coefficients and then variables, and then every single variable has a positive integer power. So the main things that disqualify something from being a polynomial is if you have a variable in the denominator, in which case you'd have a negative exponent, or if you have a fractional exponent. But if you have positive, all positive exponents, then it is a polynomial, positive integer exponents. Again, you can't have fractions. So when talking about polynomials, we have several different operations that we can do. They're kind of the basic operations that you can do with numbers. So you have addition and subtraction, multiplication, as well as division there. So this first example, we're just adding two polynomials. So if we have polynomials 5x squared plus 3x plus 1 plus 6x plus 2. And we want to add these two polynomials here. So to add two polynomials, you're just going to add or subtract like terms. And like terms, again, are those terms that have the same variable raised to the same power. So in this case, we have 5x squared, but we don't have any x squared terms in my second polynomial. So that's just going to come along for the ride here. We do have a 3x, and in my second polynomial, I have a 6x. So those two are like terms. And then we also have a 1 and a 2 here. So those are also going to be like terms. So to add these two, again, the 5x squared is just going to come along for the ride. And then we're just going to add the coefficients of the like terms here. So the coefficients are just the numbers in front of my variables. So we're just going to take 3 plus 6. So that's going to get us 9x. And then 1 plus 2 is going to get us 3. And that's how you add two polynomials. And similarly for subtraction, we just subtract like terms if there was a subtraction sign there. Multiplying two polynomials. So here we have 5x plus 2. Then we have 7x plus 3. So in this case, we have two binomials, so we can use the FOIL method. Again, the FOIL method stands for first, outside, inside, last. So to start off, we're just going to multiply the first terms of my two binomials. So this is going to be 5x times 7x, which is going to be 35x squared. Then we're going to multiply the two outside terms. So that's going to be 5x for the first one and 3 for the second one. So that's going to be 15x. Then we're going to multiply the two inside terms. So that's going to be 2 for the first one and 7x for the second one there. So that's going to be 14x. And then finally, we're going to multiply the last two terms. So that's going to be 2 for the first one and 3 for the second one, giving us 6 there. We can then add like terms. So since we have a 15x and a 14x, since they have the same variable raised to the same power, we're going to go ahead and add those two coefficients. So eventually what we're left with is 35x squared plus 29x plus 6. And then lastly, to divide two polynomials, again, we're just going to start off by doing 5x to the third plus 3x So to start off, we actually need every single power represented, and they need to be in descending order. So since we don't have an x squared term, I'm just going to put in a placeholder of 0x squared there, plus 3x plus 7 divided by x minus 3. Alright, so then to divide these two, I'm just going to say, okay, what do I need to multiply x by? So I'm just looking at the leading terms. So what do we need to multiply x by to get 5x to the third? In this case, the answer is going to be 5x squared. So I'm going to take whatever I have up here, and I'm just going to multiply each of the terms that I'm dividing by that number. So you have 5x squared times x. It's going to get us 5x to the third. And then 5x squared times negative 3 is going to be minus 15x squared. And then we're just going to subtract straight down. So just so I remember that we're subtracting, generally I like to put the signs in a little circle up here. So when we subtract a negative, remember that that's the same as adding a positive. So that just changes my sign from negative to positive. And then I can just go straight down here. So 5x to the third minus 5x to the third is going to be 0x to the third. And then we have 0x squared minus a negative 15x squared, which again, when we subtract a negative, that's the same as adding a positive. So we just end up with 15x squared there. And we should always get a 0 as our first term at this point after this step. If you don't end up with 0 here, you should probably go make sure that you chose the right number up top, because you should always end up with a 0 there. And then this 3x is going to come along down for the ride. And then we just repeat the process as long as we can here. So I'm just going to look at these two leading terms. So I'm going to ask myself, okay, what do I need to multiply x by to get positive 15 x squared? And in this case, it's going to be 15x. So I'm going to take 15x times each of those. So we have 15x times x is going to be 15x squared. And then 15x times negative 3 is going to be minus 45x. And then again, I'm subtracting straight down. So again, generally, I like to put the signs kind of up top here. And again, since I'm subtracting a negative, that's going to become a positive 45x. And then just subtract straight down. So again, we end up with 0. And then 3x minus a negative 45x. So again, that's going to be the same as 3x plus 45x is going to be plus 48x. And then the 7 is going to come along down for the ride here. And then we can go ahead and do this one more time here. So x, what do I need to multiply x by to get 48x? In this case, the answer is going to be 48. So 48x here. And then 48 times 3 is going to be 120 plus 24, so that's going to be negative 144. Again, we're subtracting, so change that negative to a positive there. So you have 48x minus 48x is going to be 0x, and then 7 plus 144 is going to be plus 151. Alright, so then to write the answer, generally we start off by writing our quotient here. So we have 5x squared plus 15x plus 48. And then generally the practice is to write your remainder as a fraction. So you have 151 divided by what we're originally dividing by here. So divided by x minus 3. So that's dividing two polynomials. So after we talked about these operations with polynomials, and looks like I have an old sheet here. All right. So after we talked about these operations with polynomials, we talked about factoring. So there's a couple different ways you can factor. So for the first one here, so we have x squared plus 3x minus 10. And I want to factor this. So factoring is kind of the reverse of multiplication. So with multiplication, you have two separate factors that you're combining together. And then with factoring, you have one product that you're hoping to separate it out into its two separate factors there. So if you have a leading coefficient of 1, as in the case here, to factor this, we're just looking for two things that when I multiply them together get me -10, and when I add them together get me +3. So two things that when I multiply them together get me the third number here, and when I add them together get me that second number. Oh, excuse me. Alright, so in this case it looks like we're looking at 5 and -2. Because if I take 5 times -2, I end up with the -10 there. And similarly, 5 plus the -2 gets me +3 there. So to factor this, I'm just going to say x plus 5, and then x minus 2. Alright. So if you have a leading coefficient of 1, it's really handy. You can just kind of go through that. Unfortunately, if you don't have a leading coefficient of 1, as in the second example here, we can't really use that handy trick like so. So if you don't have a leading coefficient of 1, one method that you can use is you can use the slide and divide technique, which converts it, my polynomial into a form kind of like this, where I can use this little trick here. So to start off, you take your leading coefficient and you slide it across. And when you slide it across, that means you're going to multiply it by your constant term. So you have x squared plus 17x. And then 15 times 4 is going to be 60 there. Alright, so now we can set up our little diagram here. So we're looking for two things that when we multiply them together get me 60. And when we add them together get me 17. Which in this case is going to be 12 and 5. Because 12 times 5 gets me 60, and then 12 plus 5 gets me 17. Alright, and then, so we did the slide step, so the method is called slide and divide. So after we get to this point, we're just going to divide my constant terms by the original value that I slid across here. So in this case, I'm just going to divide each of my constant parts by 15. So when we simplify this, so here we have a common factor of 3, so that's going to be 4 over 5. And then here we have a common factor of 5, so that's going to be 1/3. And after all this, you still end up with fractions. To complete the factoring, you're just going to take your denominator and you're just going to slide it out front in front of your x's. So you have 5x plus 4, and here we have 3x plus 1. And the last example here, example 3, so we have 8x to the third minus 125. So in factoring, there's a few formulas that you just kind of need to have memorized. So the first one is if you have a difference of squares. So if I have some quantity squared minus another quantity squared, I can always factor that as my first quantity plus my second quantity, and then the same factors but minus. So if I have a squared minus b squared, I have a plus b times a minus b. If I have a to the third plus b to the third, I can factor that as a plus b times a squared minus ab plus b squared. And then similarly, if I have a to the third minus b to the third, that's going to be a minus b, a squared plus ab plus b squared. So here we have all the variables are the same. The only thing that's changing is the sign. And the way you can remember this is with the acronym SOAP. So you have the same sign. So here, since we're adding in our original, the first sign is going to be the same. So that's going to be, so we're going to be adding for our first factor. Similarly, here we're subtracting our original. So we're going to be subtracting. So you have the same sign. The second sign is always going to be the opposite sign. So here we're adding in our original there. So here we're going to have a negative sign, and here we have a negative sign. So here it's going to be a plus sign. So you have same sign, opposite sign, and the third sign is always going to be positive. So again, we have the acronym SOAP there. So you have same, opposite, always positive. All right. So it's 8x to the third minus 125. So I can rewrite this as 2x raised to the third power, and then 125 is going to be 5 raised to the third power there. So here I'm looking at a case like this, where my a is going to be 2x and my b is going to be 5. So to factor that expression, I have a minus b, so that's going to be 2x minus 5 times 2x squared plus 2x times 5 plus 5 squared, which when I simplify all of that, I end up with 2x minus 5 times 4x squared plus 10x plus 25. So again, the main thing I wanted to talk about in that example was, again, just kind of go over these formulas again, because again, they'll come in handy later on in the semester here. All right. Solving equations. So once you have the factoring down, you're actually going to start solving equations, which solving equations is really why algebra was invented in the first place. So this is where it gets a little bit more fun here. So the first example we have here is we have a linear equation. So it's a linear equation because the largest exponent is 1. So here we have 5x plus 3 minus 2 equals 1. So to solve this, we want to get everything involving an x over on one side and everything else over on the other side. So to start off, we're just going to distribute this 5 through. So you have 5x plus 15 minus 2 equals 1, which, again, we have 5x, just simplifying here. So 15 minus 2 is going to be plus 13 equals 1. So again, I want to get everything involving an x on one side and everything else over on the other side. So I'm just going to move this 13 over. So to do that, we just subtract a 13 from each side. As long as I'm subtracting the same number on both sides of the equal sign, I'm good. I haven't changed my solution at all. So we have 5x equals negative 12, which I can divide both sides by 5. And again, as long as I divide or multiply by the same thing on both sides, I'm safe. So here the 5's cancel. So I end up with x equals negative 12 over 5 for my final answer there. Two and 3 are dealing with quadratic equations. So here we have x squared plus 3x minus 10 equals 0. So to solve a quadratic equation, you have the quadratic formula. You can also complete the square if you feel so inclined. Or you can also factor. In this case, it does factor nicely, as we saw in the previous slide. So I can factor this expression. So I have x plus 5 and x minus 2 equals 0. So if I have two things that when I multiply them together give me 0, to solve this, I can just set each of my factors equal to 0. So here you have x plus 5 equals 0. Here you have x minus 2 equals 0. And then just solve each of these equations. So here subtract 5, add 2, add 2. So here we have x equals negative 5. And here we have x equals positive 2. So those are going to be my two answers there. So if it factors nicely, you can solve the equation by factoring. However, sometimes you end up with equations that don't really factor too nicely, in which case you have to use another method there So here we have 4x squared plus 10x plus 25 equals 0. So in this case, it does not factor nicely, so I end up having to use the quadratic formula. So the quadratic formula, again, if we have a quadratic equation written in the form ax squared plus bx plus c equals 0, is we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So yeah, so that's the quadratic formula here. So at this point, we just need to know our ABCs. So I just need to figure out what a, b, and c equals here. So a is going to be whatever is in front of my squared term. So that's going to be 4 in this case. B is going to be the middle term there, so that's going to be 10. And then c is going to be the constant term. So that's going to be 25 there. And then it's just a matter of plugging those values back into my formula there. So you have x equals negative b, so that's going to be negative 10 plus or minus the square root of 10 squared minus 4 ac all divided by 2 times a. And then it's just doing the arithmetic. So here we have negative 10 plus or minus, so 10 squared is going to be 100. 4 times 25 is going to be 100 times 4, so that's going to be minus 400 divided by 8. So here we have negative 10 plus or minus the square root of negative 300 divided by 8 here. Rapidly running out of room on my page. So we have plus or minus I. So we can rewrite this as the square root of negative 1, square root of 3 times the square root of 100. So that square root of negative 1, that's where we get the I from. The square root of 100 is going to be 10. And then the square root of 3 is just going to come along for the ride there over 8. And at this point, since we have a common factor of 2 in every single term here, we can go ahead and cancel that out. So 2 goes into 8 4 times, 2 goes into 10 5 times, and 2 goes into negative 10 negative 5 times. So eventually, what we're left with is we have negative 5 plus or minus 5i square root of 3, all divided by 4. So again, the main thing I wanted to get at was, again, just a reminder of what the quadratic formula is and how we can use that in our discussions here. So after we talked about solving equations, we talked about this notion of a function. So first part, it says determine the domain and range for the function. So the domain are all the different x values that the function will take in. So here we have 1 over x minus 3. So the main thing we have to worry about at this point is there's 2 rules that we can't have. So we can't have zeros in the denominator, and we can't have negatives underneath square roots. Other than that, everything is fair game. So the only value of x that will not work would be where I have x in the denominator, or 0 in the denominator here, which means that x cannot equal 3. So that's going to be my domain. The range, so the domain are all the different x values that will work. The range are all the different y values. At this point, we don't really have necessarily a convenient way of finding the range without graphing it. So I won't really worry too much about that. But if you're curious, the range is that y cannot equal 0. Because in order for f of x to equal 0, we need to have a 0 in the denominator, which we have just a constant value for 1 there. So the range is going to be y not equal 0. Then we're also asked to find out what f of 4 equals. So to evaluate a function at a certain point, you're just going to take that point, and wherever you see an x in your function, you're just going to plug that value in. So here we have 4 minus 3, which is just going to be 1 over 1, or 1. So f of 4 is going to equal 1 there. All right. So after we talked about functions, the next thing we have talked about were graphs, and then we kind of started off by talking about all these different types of graphs, and then the next section we talked about these transformations, or how we can get from one graph to another. So this section is just kind of a review of what those transformations are. So the transformations, so if we have a function f of x, I'm just going to use x squared as an example. So I'll just say f of x equals x squared. And the first one is going to be g of x equals f of x plus 2. So that's going to be x squared plus 2. So if we're adding or subtracting outside my function definition, so this is outside the squared part, they were making this addition, that's going to correspond to a vertical shift. So if it's positive, that means that I'm going to shift the graph up. If it's negative, that means I'm going to shift the graph down. So since this is positive, I'm going to shift the graph up 2 units. So that's mainly what I'm asking for these transformations here. So here I have h of x equals f of x minus 2. Which this is going to be x minus 2 squared. So if I'm adding or subtracting inside the function definition, so inside the square part, that's going to correspond to a horizontal shift. So if it's negative, that means that I'm going to be shifting the graph to the right, however many units. And if it's positive, so if I'm adding something inside here, that means I'm going to shift the graph to the left, however many units here. So in this case, I have a negative, so I have x minus 2 squared. So that means that I'm going to be shifting the graph to the right 2 units. All right. So if I have k of x equals negative f of x, so that's going to be negative x squared. So if my negative, again, is outside my function definition, that's going to be reflect across. So if it's outside, I'm going to be reflecting across the x-axis. So I'm going to flip the graph across the x-axis. And then finally, j of x equals f of negative x. So if my negative is inside my function definition, that means that I'm going to be reflecting across the y-axis. So I'm going to flip the graph horizontally across the y-axis there. And we'll talk more about each of these. The name of this course is functions. So when we talk about the different trigonometric functions, exponential functions, we'll talk more about these transformations as well there. This is just kind of a review just to get our brains flowing and thinking about these concepts, because it's been a while since I've done math, and I'm not sure if you are feeling the same way. And the last thing we talked about are operations within functions. So if we have two functions, so we have f of x equals x squared plus 2x minus 3. We have g of x equals x minus 2. So if I add, subtract, multiply, or divide these two functions, I'm going to get a new function. And if I evaluate that function at a certain point, so if I want to evaluate the function f times g at the point 0, I can just take f of 0 and then g of 0 and then multiply those two together. So f of 0, if you plug in a 0 in for x here, we're going to get a -3. G of 0, we're going to get a -2, which gives me +6 for a total there. So you just evaluate each of your individual functions at that point, and then you perform the operation. So here we're multiplying, so we're going to multiply. If we were adding here, so if you had f plus g of 0, we take f of 0 plus g of 0. Similarly for subtraction and division as well. Alright. So the other one that I kind of wanted to go over quickly is the composition operator. So we have f composed with g of x. So the composition operator is that little circle there. So the composition operator says that I'm going to work my way from the inside out here. So I'm going to start off by evaluating g of x. And then I'm going to take whatever result I get there and substitute that in for my function in f of x there. So in this case, g of x is going to be x minus 2. So I'm going to take f of x minus 2, which is going to be x minus 2 squared plus 2 times x minus 2 minus 3. And then you can go ahead and expand this, distribute, add like terms, to simplify it. The main thing I wanted to talk about was the composition operator, so I don't really feel the need to really dive into that too deeply. Just to kind of, again, introduce this composition operator, get us back into the swing of things. Alright, so that was kind of the review of last semester. I know it's been a while since we've done math, so it's kind of nice to kind of start with a review, get us back up to speed. The next lecture will actually be starting this semester in section 3.1. So we left off talking about linear functions, and in this next section we're going to be talking about quadratic functions. So a couple of these function transformations and different things like that will make an appearance as well. So yeah, have a wonderful day, and talk to you on the next lecture. Thank you. Bye.